Welcome to Lesson 9.3, Perform Reflections. So again, we're looking at some pieces related to what we call isometries and two-dimensional translations in geometry. So a reflection is going to be another type of transformation. And when we think about a reflection, it's a type of transformation where it uses a line like a mirror to reflect an image. The line that we're using like the mirror would be called a line of reflection. So a reflection in line M maps every point P in the same plane to a point P prime, so that for each point, one of the following properties is true. If P is not on our line of reflection, then the line of reflection M is the perpendicular bisector of P prime. Meaning, if original point P was here, we're reflecting over line M from P to that line of reflection, and from the line of reflection to P prime, it has to be the same distance. And that segment created from P to P prime is perpendicular, meaning 90 degrees to our line of reflection. So if we're reflecting over that line, we're not going to shift up or down. It's just going to go what we'd consider straight across. Then if point P is on our line of reflection, its reflection point, which would be P prime, is the same exact point. So if a point's on the line of reflection, when we reflect it, it's the same point. So let's look at a few examples. So example 1 tells us the vertices of triangle ABC are 1, 3, 5, 2, and 2, 1. Graph the reflection of ABC described. So in part A here, they're saying it's being reflected in the line x equals 3. So you can think of that as over the line x equals 3. So I drew in my x equals 3 vertical line through 3. Then I graphed triangle ABC here in blue. A over 1 up 3, C over 2 up 1, and B over 5 up 2. Now, what we need to do to figure out our new points. For example, if A is here, and we're reflecting it over x equals 3, point A is 2 spaces left of that line. So point A prime would be 2 spaces right of that line at 5, 3. If B's original point, so point B is right here at 5, 2, that would be 2 to the right of the line. So then we would move it straight across 2 to the left, putting B prime at 1, 2. And then for C, if C's original point is here at 2, 1, it's 1 away from our line, so we need to go 1 to the other side, and C prime would be at 4, 1. So then we redraw the segments in, connecting A prime, B prime, and C prime, and we would have our reflected triangle. Or in B, we're reflecting triangle ABC in the line y equals 1. So if y equals 1, we're reflecting over the line y equals 1, which would be a horizontal line at a positive 1. So first we need to graph our original triangle ABC. So triangle ABC at the points 1, 3, at the points 5, 2, and at the point 2, 1. So right away what I notice is point C's on the line. So C prime, the reflection of C, is the same point 2, 1. A is 2 places above my line of reflection. So A prime would be 2 below. So A prime's at 1, -1. And B is 1 point above my line of reflection. So B prime would be 1 point below at 5, 0. Connect our 3 new points, and we have reflected triangle ABC in the line y equals 1. Then, what if our line doesn't have a slope of 0 or undefined, meaning what if it's an oblique line? So in this case, we will be reflecting in the line y equals x. So I just drew in that line y equals x right away. Crosses through 0, 0, has a slope up 1, right 1, up 1, right 1. So there's my line y equals x. So what I know right away is the slope of y equals x is a positive 1, up 1, right 1. So then what I need to do is graph my original 2 points, f at negative 1, 2, right here, and g at 1, 2, right here. So we have our segment FG. So we're going to reflect that over our line y equals x. So what I know is that the segment, if I were to draw a segment from f to f prime, it has to be perpendicular to my line of y equal x. So if y equal x has a slope of 1, my line perpendicular to that would have a slope of negative 1. So what that's telling me is that my segment f to f prime needs to have a slope of negative 1. So if from f, we're moving roughly right 1.5 and down 1.5 to get to the line, from the line, we would do the same to get to f prime. So we'd move right 1.5, down 1.5. Or if we think about it in total, from f to f prime, from f to the line, it would be down 1, 2, 3. So then I need to go right 1, 2, 3, down 3, right 3. And that gives me f prime right here. For g, to get to my line, it's down 1. So g prime would have to be right 1. So down 1, right 1 would give me a slope of negative 1. So if f was at negative 1, 2, f prime is at 2, negative 1. If g was at 1, 2, g prime is at 2, comma 1. And later we will see a rule for these examples. So example 3 wants us to go through that same process with fg, but now we're reflecting it over the line y equals negative x. So the line y equals the opposite of x, right here, passing through 0, 0 with a slope of negative 1, so down 1, right 1, means, obviously, like I just said, the slope's negative 1. So the slope of my reflection lines would have to be a positive 1. So if I'm here at f, and my current slope is negative 1, from f to f prime, if I'm moving down, then I'd have to move left. So for example, from f to get to my line of reflection, it's down 1. So then f prime would have to be left 1 from there. So down 1, left 1, and now we have f prime. For g, to my line of reflection, it was down 1, 2, 3. So then I'd have to go left 1, 2, 3 to get to g prime. So then from g to g prime, it's a positive 1 slope. From f to f prime, it's a positive 1 slope. So in this case, if f was at negative 1, 2, f prime is at negative 2, 1. If g was at 1, 2, f prime would be at negative 2, negative 1. So then we can see a rule starting to happen. If we're reflecting over y equals negative x, our current point, AB, would become opposite of B, opposite of A. If we look at this, the negative 1 moves to the back and we flip the sign. The 2 moves to the front and we flip the sign. So then we have 2 more examples before we get to our summary of rules. So in this case, they want us to graph the reflection over the given line. So in part A, y equals negative x. So I drew in my line, y equals opposite of x. And how I reflected these? Well, from A to the line, it was up 1. So to make that slope positive and slope of 1, it'd be up 1, right 1. There's A prime. B is on the line of reflection, so B prime's in the same spot. From C to my line of reflection, I had to go up 1, 2, 3, 4. So C prime would be right, 1, 2, 3, 4. And then for D, it was up 1, 2, 3, 4, 5. So D prime then from there would be right, 1, 2, 3, 4, 5. There's my points. Reconnect them, and we've reflected that figure. In B, we're reflecting in the line x equals negative 1, or over x equals negative 1, means the same thing. So I drew my vertical line at negative 1, and then what I want to do is move each point over that line. So for example, here is B, and it's 1, 2, 3, 4 away from that line. So without going up or down, I'd just go 1, 2, 3, 4 to the right. C is 2 away from that line to the left. So to get C prime, I'd start at the line and go 1, 2 to the right. A is currently 1, 2, 3, 4, 5 spots to the left of the line. So A prime would be 1, 2, 3, 4, 5 spots to the right. Reconnect our 3 points, and we've reflected that triangle. So then we get to our 4 easy rules. So you don't need to worry about those opposite slopes as long as you remember these rules. So for example, if we have our original point AB and we're reflecting over the x-axis, so we're reflecting over this axis right here, x-axis, which would be if y equals 0. So if we're reflecting over the x-axis, y equals 0, and our original point AB, our new point of reflection would be A, comma, opposite of B. If we're starting at AB and we're reflecting over in the y-axis, so we're reflecting over x equals 0. In that case, our original coordinate AB becomes the new coordinate opposite of A, comma, B. Then if we're reflecting the coordinate AB over the line y equals x, it's as easy as flipping the coordinates, so AB becomes BA. And then our last one, if we have the coordinate AB reflecting over y equals the opposite of x, then our new point is opposite of B, comma, opposite of A. So if we just keep track of these 4 rules, they show you how to deal with reflecting over these 4 special lines. And then we get to our last idea for this lesson, which is the reflection theorem 9.2. Theorem 9.2 simply states a reflection is an isometry, meaning any figure we reflect will be congruent to its original preimage.